Good evening. Welcome to the QCIS channel. We're on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to get into a field that not too many people talk about, but the FHWA and a number of the state DOTs talk about this branch of engineering. And it is a branch of civil engineering. And I'm going to talk about subsurface utility engineering. Now, when new roads or new infrastructure, whether it's a bike trail or it could be a new railway, it doesn't happen with railways. Railways usually have their own right of ways, but this happens when they're putting in new roads, maybe a shopping center, where you have to look at utilities. And when I talk about subsurface, talk about utilities below the surface, like your water, your gas, your sewage, your cable. A lot of times we deal with the above ground or the surface utilities, like your above ground power poles. What do you do with your gas lines? That's another utility. Well, some places they call them utility coordinators. Here I'm talking about subsurface utility engineering, and they do take the risk. And again, they deal with all of the underground utilities. And it's very important that you don't hit a gas line. You don't hit a cable line. Now, it does happen. But this is why if you engineer it right with a good utility coordinator, and this is why you have to have meetings as well to ensure that this doesn't happen. I'm just going to tell you this. In my years of construction, utilities happen to be the worst, whether they're above ground or whether they're below ground, because somewhere along you have to prevent from hitting everything below ground, and then above ground you have to relocate them. So you need to know where your utilities are before anything can get built. Now, unfortunately, utilities put a lot of delays on projects because there's so many of them. Like here in Indiana, we have AES, we have Citizens, and we have cable, we have fiber optics. But it's very important because a lot of our services run off of public utilities. I know living in an apartment, water line gets cut. What does the apartment complex do? They cut everybody's water off. That's the same thing that will occur if a utility is breached out there when construction is going on. Let's get into the PowerPoint. This is the fun stuff. So again, some of this information goes back to 2000. I am presenting it tonight, but this presentation has already been delivered, but you need to hear it again. We're going to talk about the cost savings on highway projects that utilize subsurface engineering. It is very important. Now, again, the FHWA, which is the Federal Highway Administration, commissioned my alma mater, Purdue University, to study the effectiveness of subsurface utility engineering, SUE, as a means of reducing costs and delays on highway projects. Now, previous studies and statements of cost savings were performed by various state DOTs, providers of SUE services, and the FHWA. Now, commissioning Purdue University to conduct this study allowed for an independent and impartial review and study of cost savings. Now, there were 4 states that did participate: Virginia, North Carolina, Ohio, and of course, Texas. Now, Virginia DOT Advantage, oldest program, started in 1986, and most comprehensive use of SUB mapping in the country. Every state DOT project gets QLB and QLA mapping. Disadvantage: no recent database of claims, change orders due to not using QLB and QLA mapping. Now, North Carolina Advantage, program in development, used for approximately 6 years. Many projects to choose from. Now, some system in place to track utility change orders, claims during construction. Now, disadvantage: at that time, did not use QLA mapping, only QLB, mostly used in urban and suburban projects, few rural ones. Well, that's because in the urban areas, you actually have more utilities. Now, designers typically got data late in their design process, so not used as effectively as possible. Now we get to the Buckeye State, Ohio Advantage, program in development, used for approximately 4 years. Aggressive program administrator kept track of past and present utility change orders, claims during construction, used both QLB and QLA mapping. Now, of course, disadvantage: only used in several districts, suburban in nature. Again, in the suburban areas, you have more utilities. Texas Advantage, new program, used for only 2 years. Recent history of past and present utility change orders, claims during construction, used both QLB and QLA mapping. All types of projects. Now, their disadvantage is, or we can say was, most projects were not yet in construction. So, the general investigative procedure, this is how it would work. You pick projects as randomly as possible, interview DOT personnel, SUE consultants, utility owners, contractors, and designers, review statewide utility claims histories, review project plans, utility records in detail. Again, utility DOT contractor personnel missing in action, retired, or unable to remember specifics. Then, of course, you have the state DOT's record of claims, change order history poor, she worked out and bartered by construction engineers or hidden in unrelated cost categories. Now, of course, there was a checklist developed of 21 areas for potential project savings. Now, it did not differentiate between savings to utility owner versus DOT. Now, when it comes to savings, there are areas in savings. Well, you can have a reduction in unforeseen utility conflicts and relocations, reduction in project delays due to utility relocates. You can have reduction in claims and change orders, reduction in delays due to utility cuts, reduction in project contingency fees, lower project bids, reduction in costs caused by conflict redesign, reduction in the cost of project design, reduction in travel delays during construction to the bordering public, improvement in contractor productivity and quality, reduction in utility companies' costs to repair damaged facilities. Areas for savings again. We're dealing with minimization of utility customers' loss of service, minimization of damage to existing pavements, minimization of traffic disruption, increasing DOT public credibility, improvement in working relationships between DOT and utilities, increased efficiency of surveying activities by elimination of duplicate surveys, facilitation of electronic mapping accuracy. This is when you get GIS involved. Minimization of the chance of environmental damage. Inducement of savings in risk management and insurance. We have the introduction of the concept of a comprehensive SUE process. And we have a reduction in right-of-way acquisition costs. Now, some of you may join a little late. When I mean SUE, I'm talking about Subsurface Utility Engineering, and it's used by the FHWA and, of course, 4 DOTs, Virginia, Ohio, North Carolina, and Texas participated in this study to try to reduce costs and savings for projects that utilize a number of these utilities. Now, most of the studies were not in the rural areas, they were in the urban and suburban areas. Now, I did say again, you have a lot greater or dense populations in the urban and suburban areas. So therefore, you're going to have more utilities where it's less dense, and you're going to have less subsurface utilities in the urban areas. In fact, most of your utilities are above ground or above surface utilities. Now, many of these areas could not be quantified for a study. Now, the reductions in risk for projects utilizing SUE have been difficult to quantify. There are many variables and scenarios that may occur. Historical data is difficult to come by, so some savings are usually quantified, others may be qualitative or speculative in nature. This study categorizes savings accordingly to these types of costs. Exact cost that can be quantified in a precise manner. Examples of cost, much like the cost for test holes, the cost to eliminate construction and utility conflicts, or any other cost which exact figures can be attained. Again, you have examples of cost, much like the cost just for test holes. Now, what do I mean by a test hole? Well, a test hole could be a boring, getting ready to go out, get a piece of land, you run a test bore to see what kind of soil you have out there. Make sure you have good soil so your building won't have differential settling. Well, that's the same idea when it comes to the cost to eliminate construction and utility conflicts or any other cost for which exact figures can be obtained. That's what we're talking about. Now, estimated costs that are difficult to quantify but can be calculated with a high degree of certainty. These costs were estimated by studying projects in detail, interviewing the personnel involved in a project, and applying historical cost data. Now, for costs that cannot be estimated with any degree of certainty due to a lack of data, these are true qualitative costs and may, in fact, be significant to the real cost savings. Now, these qualitative costs are not quantified in the evaluation study. So it is believed that the majority of savings fall into this category. Therefore, the cost savings reflected from this study are a minimal quantifiable savings. Now, these project savings are likely to be significantly higher than this study can prove. Now, study results in Virginia studied 9 projects, total construction value of $42 million, cost savings of QLB, QLA mapping over QLD, QLC mapping was a minimum of 412%. Then we had a project delivery time savings of 12% to 15%. When I talk about QL, just so you'll know, the type of mapping, QL stands for quality level. Just remember that. So you have 4 different levels when we talk about savings. And I'm going to get to that at the end of this presentation. So, getting to QLB mapping identifies an average of 10% to 50% more utilities than traditional mapping of QLD and, of course, QLC. For North Carolina, studied 21 projects, total construction value of $205 million. Cost savings of QLB mapping over QLD, QLC mapping was a minimum of 663%. So SUE budget is approximately 2% of the total state DOT budget for engineering and construction. So basically, the majority of projects utilizing SUE showed no delays due to utility conflicts and an improvement over the past data. For Ohio, studied 14 projects, total construction value of $284 million. So cost savings of QLB, QLA mapping over QLD, QLC mapping was a minimum of 521%. SUE was initially used to solve field utility conflict questions, could be more effective if used earlier in the design. Now for Texas, studied 28 projects, total construction value of $606 million. Now you have cost savings of QLB, QLA mapping over QLD, QLC mapping was a minimum of 427%. Projects only used on interstate projects, urban municipal projects not evaluated, but savings on these projects should be even more. Now, from a study of 71 projects with a combined construction value in excess of $1 billion, the results indicated the effectiveness of the study was a total of $4.62 in savings for every $1 spent on SUE. So the cost of obtaining QLB and QLA, except NCDOT data on these 71 projects, were 0.5% of the total construction cost, resulting in a construction savings of 1.9% by utilizing SUE. So, in other words, qualitative savings were non-measurable, but it is clear that those savings are also significant and may be many times more valuable than the quantifiable savings. So, out of these 71 projects, only 3 had a negative return on investment. One individual project had a 206 to 1 investment on an NCDOT project. So one individual project had a 206 to 1 return on investment. That means 206 to 1. You put $206 in, you're getting $206 back. It's a big return on investment. Now, this leads to the conclusion that SUE should be used in a systematic manner, i.e., on virtually every project. So, utilizing the data from this study and given a national expenditure in 1998 of $51 billion for highway construction, the use of SU in a systematic manner should result in a minimum national savings of approximately $1 billion a year. Now, QLB, QLA mapping budgets should be approximated, or let's utilize it this way. QLB or QLA budgets should be approximately 1% of the state engineering and construction budget. Again, QLB, QLA mapping budgets should be approximately 1% of state DOT engineering and construction budget. Now, this study shows a potential minimum stretching of project dollars by 4.62% if comprehensive QLB, QLA mapping is performed correctly. And finally, state DOTs and their consultants should integrate this SU mapping with pending ASCE, which is the American Society of Civil Engineers, and then ANSI, which is the American National Standards International, which they set, they're like ISO. So they set basically standard guidelines. Again, that's standard guidelines for the collection and depiction of existing subsurface utility data. Now, again, they're probably using it more now. This came out back in 2002. Sometimes I'll go back and use some old data so you'll get an idea of where the project originated. Now, when we deal with, again, subsurface engineering, again, it's a branch of engineering that manages risks associated with mapping underground utilities for projects like highway construction. It involves a process of determining the horizontal and vertical location of utilities through different quality methods or quality levels. We'll say different quality levels, from simple record research to precise excavation. SU helps reduce cost. It definitely prevents construction delays, and it minimizes damage to utilities. Now, when I talked about the QL, this is what I'm going to tell you. Give you the SU process and the quality levels. QL stands for quality levels, whereas SU stands for Subsurface Utility Engineering. Now, under the SU process and the quality levels, the American Society of Civil Engineering has defined a 4-level system for assessing the quality of utility data. Now, here's where you get all the A, B, C, D from, and I mentioned all the QL. So we have QLD, which is quality level D. It's based on available records such as as-built drawings and oral histories. And we have quality level C, which is QLC. It involves surveying and mapping visible above ground features that are presumed to be related, again, to be related to underground utilities. Then we have quality level B, which is QLB. It involves using geophysical technologies like ground penetrating radar, which is GPR, to non-destructively locate and designate the approximate position of underground utilities. Now, what they're talking about is a instrument. Let me give you an example. When I'm out there surveying, there's an instrument that makes noise, a metal detector. Schonstedt makes it. You hold it in your hand, and what you're doing, you're locating something that you can't see, a property pin. It could be a pipe. It could be a wagon wheel. Well, the radar, that's exactly what it's doing as well. You're trying to locate a utility that you can't see, but it is there. Now, you also have quality level A, QLA. It's the most precise level where utilities are exposed to minimally intrusive excavation, such as vacuum excavation, to determine their exact horizontal and vertical location, and of course, condition. Now, the benefits of subsurface utility engineering: cost reduction by avoiding unexpectedly utility discoveries during construction. Again, it's always big to reduce costs. And under cost reduction, what's happening here is you avoid unexpected utility discoveries during construction. Again, cost reduction. You're avoiding unexpected utility discoveries during construction. Fewer change orders, which minimizes design changes that occur after construction begins. Fewer interruptions. It prevents work from being stopped due to utility conflicts. Improves safety. Reduces the risk of accidents and damage to infrastructure. And of course, better project planning. It provides accurate data for informed design decisions. And once again, when we talk about SUE, subsurface utility engineering, it's a branch of engineering that manages risks associated with mapping underground utilities, projects like highway construction, because it involves the process of determining the horizontal and vertical location of utilities through different quality levels of determining the horizontal and vertical location. That's the horizontal and vertical location of utilities through different quality levels from, again, simple design or simple record research. That's simple record research to basically precise excavation. And again, SUE helps reduce costs, prevents construction delays, and minimizes damage to utilities. Now, this is why you saw in the presentation where you had QLA, QLB over QLC and QLD. Well, why was that? Well, again, C and D relied basically on as-builts and survey, where QLA and B relied on you take a piece of equipment out there to locate the utilities, and the most precise level is excavation. Why? Because once you excavate down, you can see the utility. That's why A and B are much better than C and D. But that's basically what SUE is. You're dealing with utilities to find out where they are, see if you have to relocate them, or basically to see if there's a conflict when you are getting ready to build a new road. Because when it comes to road construction has a lot of hazards that we really don't talk about. We look more at building construction with most of the hazards, but road construction, you deal with the wildlife, you deal with the utilities, you even have to deal with relocating people from their homes when it comes to right of way, eminent domain. But again, we're dealing with utilities that you can't see below the surface. Now, something you need to know, a lot of the utilities are color coded, they're marked, so you know they're underground. And that machine, it does locate them. That's one thing that I didn't mention in the PowerPoint. Look on a legend, and if you see like red, you see blue, which is water, or green, or orange, which could be electrical. Your map will tell you that legend, and then you can see the markings out there on the road where the underground utilities are. So there are different ways of looking for underground utilities, including GIS. And that concludes this topic on subsurface utility engineering. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and social content, check out my main channel, the 411 Talk Zone Radio Show channel. Now, here's where you can find me. 411 Talk Zone Radio Show channel. You can find me on YouTube, find me on X, formerly Twitter, True Social, and Rumble. And for the QCIS channel, you can find me right here on YouTube, X, formerly Twitter, and of course, the QCIS channel is on LinkedIn. And let me say something about LinkedIn too that I'm not liking. I put my videos so people can look at them on LinkedIn. What I don't like is I'm getting the calls about my business quality control inspection services. And I'm getting people that don't know me. They know my name because I do mention my name in my videos. I'm not interested in selling quality control inspection services, and I'm not interested in any of your services. I primarily post my videos on LinkedIn so people get some education on STEM. So if you are not part of STEM and I don't reach out to you, well, you're just wasting your time because I'm getting calls about funding for my business, the scam calls. I'm not going to be available. So again, don't waste your time and don't make me get nasty either because again, I'm out here giving an education to individuals who are interested in in STEM, science, technology, engineering, and math. If I want some business, I know who to go to right here in the Indianapolis area. And I don't need to make a phone call to some out of state person I will never see. I can do it personally right here, probably for less money and less time. But again, thank you for viewing this content on Subsurface Utility Engineering from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.